Hello, and welcome to the Culture Track at the 3rd Annual Python Web Conference. I'm Laura from 6 Feet Up, and I'm thrilled to welcome Rob as our final presenter.
I'm really excited that I get to present here at Python Web Conference. Today, we're going to talk about the definitive deep dive into the .git folder. Now, death by PowerPoint is definitely a thing, so I have no slides. This is it. You can reach me on Twitter at rob_rich and my website, robrich.org. We're going to dig into objects, refs, logs, hooks, configuration, temp files, indexes, all of the things inside of the .git folder. Now, you've probably used Git a whole lot, or maybe you haven't, but that .git folder is probably a mystery. Let's dig in and make it good. So I have here an empty folder. Let's make it into a Git folder. Git init. Now, we could have cloned a repository, and that would do a similar thing and also give us some history, but this will give us just an empty directory. Now let's create some content. Let's echo file1 into file1.txt. Git add file1, we'll add that to our staging directory, and then git commit -m file1. Okay, now if we say git log, we have some content here in our repository. Let's open up this new .git folder in VS Code and take a look around. Now this directory, it is magic, and you really can't break anything in Git unless you change content here in this .git folder. So maybe the best way to back up a Git repository is just to back up this .git folder or to push your changes to another Git repository. Now we have a whole lot of things in here: index, head, description, config, commit, refs, objects, logs. Let's start with objects. Now here in objects, we have all of the content that we just committed. Well, we actually have 3 things here. Now each one is a zlib compressed file. If we look at this, yeah, that's garbage. Well, no, it's zlib compressed content, but we do have 3. So let's come back to our console and take a look at it. So we can go look at each of these files. How do we unzlib compress them? Well, we can come in here and we can cat them. PigZ is a program that can do it. There's other Python programs that will allow us to unzlib compress them. I've created a program here called Unzipper, and Unzipper just does that. Go grab zlib, go grab fs, and let's just read the contents and output it to the screen. So let's use Unzipper to take a look at some of these things. I'm going to look at .git /objects/ and now I have these 3 pieces. So let's say unzipper.git /objects/0b, and let's unzip this one. So here's the contents of that file. There are 3 nulls. This says tree 37, 0644. This looks like some file information. Let's unzip one of the other ones. Let's look at 37. And this one looks like commit details. Here's my name, the date time that I committed it, and the tree node. Well, 0b9f, that's the one that we unzipped up here, 0b9f. Okay, let's unzip the last one. Unzipper.git /objects/e2. This one says file1. Ooh, that's the content that we put in the file. So we can see that there are 3 different types of blobs in this objects folder. We have a commit node, we have a tree node, there's the tree, and we have a blob node that has the actual content. Now we can use git commands to take a look at this as well. So let's say git cat file -t, and let's look at E212. Here's the type of that one. It's a blob. We can do the same thing for 3.7 and 3.7.5.3, and that one is a commit. So let's take a look at the contents of that commit. Git cat file -p, and we'll look at 3.7.5.3. Here's the contents of that commit. Now it does reference this tree node, so we can say git cat file -t 0b9f. It's a tree node. Let's do -p, take a look at the contents. It says here's the permissions on that file. Here's the blob that references that file. Here's the file name. And here's that blob that it is. So git cat file -t, that blob, yep, it's a blob, -p. And here's the contents of that file, file1. So that's kind of how the objects folder works. Let's go create another commit. Git echo file2 into file2.txt, git add file2, git commit -m file2. And now we have 3 more nodes. Let me refresh this. So we had this one, this one, and this one. Now we have 3 more nodes, a new commit node, a new tree node, and a new blob node. Well, how do those get created? Let's say echo file3 into file3.txt. Do we have new folders yet? Nope, we still just have those 6. Git add file3. Now that we've added it to the staging area, let's take a look. And we do have that one new node. Git commit -m file3, file3.txt. Oh, no, git commit -m file3. And now we have all 3 of those nodes. That's interesting. As we added things to the staging area, it added that content, those blobs, into our Git repository. Well, wouldn't it be nice if we could, I don't know, visualize this? Here's a Git repository, github.com/robrich/git-explorer that allows us to visualize a Git repository. Take a look at all of these objects. So here inside this folder, I pass it the path to my repository that has the .git folder in it. And when we do, now we can pull this up and let's reload our thing. Yep, here's all of the commits that we have, and we can kind of take a look at them. If I click on one, here's the contents of that piece. In this case, it was a tree node. That's cool. Here's a different node. It's a blob node. Well, let's make them alphabetical and show the tags so that we can see what each one is. Okay, so this one says main and head. I have my branches on there. Here's the details for that one. Maybe it references CB9. So let's go find CB9. Here's that. And here's all of the 3 files in this particular tree node. Now it references 3 files. Here are the 3 blobs, and we could reference each one. Let's reference it not by alphabetical, but instead flip it to be parent-child. Let's show the type so that we can see commits, trees, and blobs, and I'll show lines so that I can connect them. Here's our original commit. There's that commit. It says file1. It references this tree node, and that references this blob node. When I did commit 2, here's file2. That's the commit message. My name, email, date, time. That, by the way, is why it asks you for your name and your email when you first configure Git. And this tree node references 2 files. Now it references the original blob that we had created, and it also references the new blob that we had created. Here's our 3rd commit. And so now we have that commit. It references this tree, which references 3 different files, of which it references this new file. So it's actually referencing our original file and this new, file 2 and this new file 3. Well, what happens if, for example, we create a new folder? Let's put a folder right here. And now let's say echo file1 into folder/file1.txt. Git add folder/file1. git commit file1 in a folder. Oh, -m. Git commit -m, file in a folder. Okay, so we should have those 3 new commits. Let's refresh this. We'll put it in parent child, show the type, show the lines, show the tags. Yep, we have our new commit. We have our new tree node. And notice it references this folder tree node. So we have a second tree node, 0b9f. Here's 0b9f. And hey, 0b9f, that's the same tree node that our original commit used, and it's referencing this exact same file. The other thing this is doing is referencing file1 from this original blob e2f. We have 2 pointers to the exact same blob. If we add the same file into Git in 2 different folders, it doesn't make our Git repository bigger. It references the same file. Well, let's change a file. Let's open up file2 and we'll add some changes. And now let's git add file2. Git add file2, git commit -m, change file2. And let's go refresh this and take a look at it. Let's show the type, parent child, show the lines, show the tags. Here's our new commit. It references this content. And we see that it's referencing file 1, 3, and the folder the way that our previous ones did. But it now has this new blob, 3FA. Here's 3EFA. Here's this new one with the content changes. So as we modify our files, it creates a new blob with those differences. Now, what happens if we amend a commit? So I want to change file 2, but I also want to change file 3. Changes. So now let's git add file 3 and git commit. And I'm going to say amend -m change file 2 and 3. So now if I say git log, I see that I have change file 2 and 3, but I don't have the commit for change file 2. I amended that commit. I changed it. Is that a good way for us to remove our secrets from our repository? I'm just going to overwrite that commit and not show it anymore. Well, here's our new commit that references changes to file 2 and 3. Here's our original commit. It's still there. Now, in time, Git will start to reclaim these unreferenced commits, but it'll be 2 weeks by default, and maybe longer, depending on who cloned the repository. If I were to push this up to GitHub and then quickly amend it and push it up to GitHub again, the content is still there. If you've committed secrets to GitHub or to Git, you should consider those secrets lost, whether you've published it to GitHub or to Bitbucket or just emailed a diff. That content is still in your Git repository, even if you amend that commit to change it. Okay, so we got a sense of how our Gits look. Let's say Git log. Now this is a little bit heavy. Let's say Git log --1 line. That will kind of give us 1 line per thing. We can also add --decorate. That will give us our branches. I actually had that turned on in my global Git config. Graph. Graph will give us this ASCII chart. Now, right now, we don't have any branches or tags, but we get a feel for how that works. So let's actually look at that. One thing to reference as we go, we did ignore this pack folder and this info folder. If we were to say git gc, and I'm not actually going to do this, then that would pack all of these commits into pack files. And so we wouldn't have all of these objects right here. Instead, they would be one combined pack file in here. Now, git gc gets run automatically if our repository is of sufficient age, so we don't need to worry about it. We want to take a look at branches and tags next. Here in the refs folder, let's close objects and take a look at refs. We have heads, and we have main. Ooh. We also have this head thing. Okay, so it says refs heads main. Okay, let's open up refs heads main. Here's refs heads main, CF8F20. That looks familiar. That's the commit for the thing that our branch is pointing to. Head points to main points to this commit. So let's check out a different commit. Git checkout 6db6f. Okay, now let's go look at our repository and we'll come back to this really scary message. If I open up refs heads main, it still points to the same thing. But if I open up this head file, it points at that 6db67. That's the commit that our head now points to. If we do a git log, we can see that head points to this commit. Now, what is this? You're in a detached head state. A detached head state. So like I took off my head. Are we in this zombie apocalypse thing? What Git is trying to warn us is that our head doesn't point at a branch. Our head just points at a commit. Now we could definitely continue on committing content here and creating new nodes in our objects folder, but the Git GC will notice that there are no branches pointing to that and remove it. What Git is telling us here is that really we need to create a branch. Okay, Git checkout -b will create a branch right away. New branch. And now Git log --one line --graph --decorate. Now we're no longer in a detached head state. Our head points at a branch instead of pointing at a commit. Let's go look at that in our .git folder. Head now points to refs heads new branch. Refs heads new branch. And here's our new branch, 6db6714. That's what the refs folder is it's the commits of each of these other things. Now I can create a tag, git tag 1.0, and that as well will show up in our refs folder. Now we have something in tags. Here's 1.0 and the commit that 1.0 says. Okay, so yes, technically I could say, let's move this tag by changing its commit, and that would work just fine. Git log one line graph decorate. Oh, let's actually show all commits so that we can see not only the ones that we have, but also our parent commits. And we see that we just moved that tag. Now, that's not a great way to move tags, but that's exactly how these files work. Okay, let's talk about how remotes work. Well, right now I have here this folder. Let's build a server. Now, I don't have anything in the server folder, so let's create a new terminal and we'll cd into this folder. It's an empty folder. Let's git init, but instead of just git init, let's --bear. --bear will create a server-centric Git repository. Now we see that it's pretty much the same as our .git folder. It's just the contents of the .git folder. We don't have a .git folder. We don't have a working directory, a checkout. This is perfect for servers when we just want to keep track of our content. Okay, now in this repository, I have all the standard things. Objects right now is empty. I have no refs. It's just an empty repository. Let's come back in our regular repository and let's say git remote add. I'll call it origin, though it doesn't matter what that branch name is. And I'll give it a URL. There's my URL. Now, in this case, it's a path in my file system, but it could also be a path on a file share, or it could be a URL up to GitHub or Bitbucket, git remote -v. I now see that I have the remote, and yeah, I could separate fetch and push directories, but we never do. Git log --one line --graph --decorate --all. Let's git push main to our server origin. Actually, let's git push origin main. Now, why is it origin and then main? Because I could push multiple directories. Let's push main and new branch and 1.0. Cool. Now that we've pushed all the things, if I say git log --one line --graph --decorate --all, I'll see not only do I have my content, but I also have where I thought the server was last. Flipping over to our server folder, we now have in the objects, we have all of those objects associated with that content on the remote. In our own .git folder, now not only do we have refs for ourselves, tags, heads, but we also have remotes. Now I chose to name my remote origin, so I have an origin folder right inside that remotes folder. And here's main, new branch. Here's where I put those things on the remote server. So main is cf8f2, and that's exactly the commit that we have for our main, heads main cf8f2. So remotes are no different than tags or branches. We're just specifying that here's where I knew the server was last. So when I say git pull origin, what I'm doing is I'm saying, hey, go get all of the details from that remote one and let me update my pointers to match where that remote server is. Now I need to say git branch -u origin main, and now I can pull. Okay. So now I've got my content, new branch, and main are, oh, I actually pulled main into place. So that was a little interesting. I set my upstream branch to main instead of setting it to new branch. So let me actually fix that. Git branch -u origin new branch. Okay, so now that we've got our content in place and we've taken a look at refs, let's take a look at logs. Now here in our .git folder, we have a few different logs. Here's a logs folder and we have refs, heads, main. Okay, so here's where main was, and then main moved to here, and then it was here and it moved to here. Have you ever been in that spot? And let's actually get into that spot. Git checkout 6db6714 git checkout -b second branch. Now we're not in a detached head state, so we can see that we've got our logs set correctly. Now I'm going to echo file5 into file5.txt, git add file5, git commit -m file5, git log --one line --graph --decorate --all. Now we've got this second branch and everything is going great. Git checkout main. Okay, I think I'm done with second branch. Git branch -d second branch. Git log. Oh wait, my content is gone. Well, it's not gone. My pointers to it are gone. Now, eventually Git GC will clean up after this and we will lose that content. But right now we can use Ref Log for exactly this mechanism. Let's go look through these logs and get a feel for where we are. Git Ref Log. So main was here, and then it moved to here, and then it moved to here, and then it moved to here. And so we can see our history of where we went. That's really cool. Let's say Git Ref Log second branch. Nope, that didn't work. And so eventually we can get back to this commit. Now, if we haven't run too far away, we can say git checkout that commit. We are in a detached head state, so let's git checkout -b new second branch. And now we've got our content back. The content isn't gone, and Ref Log is a great way to get that content back out. Now, parsing this ref log by hand is a little weird. That's why looking through it with Git Ref Log is really great. But I have a log for main, new branch, second branch. I can have a log for my remotes, and I can understand where each of those branches has been and get a feel for that. Git Ref Log, sometimes I like to think of it as reflog, but that's where I'm doing. I'm looking through my refs for the log of all the content that I've gone there. So Git Ref Log is a really handy way to be able to cruise through these logs. And by default, when I say Git Ref Log, I'm actually looking through head. And so here's the history of where head went. It went here and then it went here. I have both the old commit and the new commit so that I can understand where I'm going. Next, let's dig into hooks. We have this hooks folder. And if we look at the hooks folder, we can see that we've got these .sample files. Now, this is a shell script. I am running on Windows, but Git has the Linux pieces in place to be able to run these bash scripts. Now, right now they're .sample, so they're not actually run. But if I just create a file that happens to have this name, apply patch-msg, commit message, fs monitor, post, if I create files that match this, then I can do some interesting things. And they do have some good examples of what we might choose to do here. But I'm going to reach into my stash and I'm going to look for some hooks that I have that are just examples. Now, in this case, rather than doing anything interesting, I'm just renaming from .sample to not .sample. And I'm just echoing the thing that we're doing and echoing the input arguments that we get. So if I'm going to do a commit, I'll say, here's the commit message hook, and I can do things. Pre-push commit, here's the pre-push commit, and here's the things that we'll do. Okay, so I want to say echo file 6 into file 6.txt. No messages yet. Git add file 6. Nope, there are no hooks associated with adding things to the staging area. Git commit -m file 6. We now see that we get a pre-commit hook, a prepare commit message hook, a commit message hook, and at each of those places, we could take actions. Perhaps in a pre-commit hook, we want to run our unit tests or maybe just our linter. Maybe in the prepare commit message hook, we want to validate that we've got our correct syntax so that our CI system or our release note system can read those commit messages and take action. Maybe we need to document which JIRA task or which task tracking system number we used to build this action. So all of that content we can use in these scripts to take action. Git push origin. I'm going to push this branch up to the server, and we see that we get this pre-push hook. Maybe I can't push if my tests don't pass. That's great. Git log -- one line -- graph -- decorate -- all. Now, we did modify a bunch of these files in the hooks directory. So can I say git add .git /hooks / well, no, because it's inside the .git directory. I can't really add content into my repository, so I can't really share my hooks with you. So that means that we would need to, well, copy this content to all the machines. That's a little unwieldy. Git hooks is a node package that allows us to do exactly that. Now, Git hooks will actually reference scripts outside of the .git directory with symlinks inside the .git /hooks directory. So I npm install git hooks, and now I can run hooks on my content. Now, here's the .git hooks folder, and so I can have just regular scripts. Maybe they're bash scripts or node scripts or Python scripts, and now they will run as my package is set in place. I can check in the .git hooks directory, and as I npm install this git hooks package, it will actually wire up the symlinks that I need to be able to reference the hooks elsewhere. So hooks can be a really powerful mechanism to be able to pay attention to the things happening in our repository and take action based on that. We looked at objects, refs, logs, hooks. Let's look at configuration. Now, this config file is really cool. This config file lists all of the particulars specific to this repository. Now, in this case, I've specified my remote named origin, and here's the URL to get to that remote. I may have different mechanisms to be able to fetch and push to it. So maybe I'll specify here. I also have some other details associated with this. Now, this repository's config file actually overrides any particulars that I have set in my .git config in my user directory. So this one is in C users rob.git config. And here in this .git config, there's my user name and email, my GitHub user. I've specified some diff and merge tools, my editor. I also have some interesting aliases and different details here. So, well, what if I want to have a different email address associated with this particular repository? Maybe this one isn't my personal account. Maybe this is a corporate account and I need to change that. Well, I can just put these config values here. And instead of being robrich@robrich.org, I'm going to say robrich@mycompany.com. Now, all the commits that I make from here on in this repository will use different configuration values. Now, what's interesting about this config file is that not only is this config file overriding my user profile git config file, but this user specific git config file is overriding the host specific config file. This one is installed on my machine. This one happens to be in C, program files, git, etc, git config. But if you've installed this on another system, it might be in a different directory. Now, this specifies some of the root pieces that I chose as I installed Git. Did I check the box that says auto carriage return line feed? Did I use the credential manager, the helper manager core? Those are the pieces that I chose as I installed Git, and these are where it saves it. So here's the base level things in the Git config file. I then override those based on my user profile Git config, and then I override those based on the configuration inside my repository. I now have 3 different levels where I can configure things. So is this an organizational specific setting? I may choose to put it in my user profile. Is this specific to this particular repository? I may choose to put it in my repository's config file. Now, it's easy to think, well, I just want to put it in the machine's config file, and that's tempting. But next time you update Git, it's going to overwrite that file. So be careful with that. It's best to override it either in your profile or in the repository's config file. Now, that's one config file. If we want to look at other config files, here inside info, we have an exclude. Now, this looks like a .git ignore file. And in fact, it is. I could specify ignore node modules, bin, obj, star.user, star.log. I could ignore all the files here. But this is inside my .git folder. I can't commit this. And because I can't commit this, it's probably better not to put this here in this configuration file, but rather to put it in my regular repository. Echo node modules into a .git config or .git ignore. Now I can say I would like to add that to my repository, git add.git ignore, git commit -m git ignore. Now I've got that content in my repository. Though I could put it here in this exclude folder, it's best to treat like this exclude file doesn't exist. There's also a description here. Now, this description file is used by Git InstaWeb, and you may not have used Git InstaWeb, but Git InstaWeb is a web server built into Git that if you're running Git on Linux, you can host your own web server. Now, we probably use GitHub or Bitbucket or Atlassian or something like that to host our repository, so we've probably never seen this. If you wanted to change the name of the repository in Git InstaWeb, you can definitely do that here. Index. Index, this is a binary file. Now, it is a configuration file, but it's messy. If we want to go look at what is an index file, we can go prune it in and look through various things. And there's some description about what are all the pieces in this Git index file. But I found that this gin program is good for being able to parse the Git index file. Or, like noted here in this file, Git ls-files will actually be able to do that as well. So let's do that. Let's say Git ls-files, and we can see all of the files, 1, 2, 5, 6.gitignore. Well, why would we have this index together with the hash of that blob? Well, as Git wants to do a really quick diff to be able to see what is the difference between our working directory and what's at this commit in our repository, it needs to be able to quickly look through an index. Now, it could traverse the commits to the trees, to the blobs, but this index allows it to just quickly get to the blobs straight away. It reads this one file. It knows all of the files in my working directory and can diff them really quickly. So that is this index file. Now, it is a little weird. I definitely don't want to parse it myself, but it's nice to know that that cache is there. Temp files. We have commit edit message here, and it's git ignore. Now, as we pass this commit message into our pre-commit hook, it does so by passing in this file name. So this temp file, this commit_message, is that message that we're passing into our Git hook. Now, the temp file is created whether we're using a pre-commit message hook or not, but we can pretty well ignore it. We might have a commit message in here. Origin head is another one of those temp files where we're passing that content around. And here in info, we might have a refs file that might also be a temp file. So we looked at a lot of different pieces inside of our Git folder. We have hooks that allow us to take control over various pieces. We have info that allows us to exclude things based on configuration. We have logs that allows us to get back to commits that we've lost. We have objects that store our actual content in our repository. We have refs that allow us to navigate quickly to a particular commit and to name them in interesting ways, also to keep track of where they are in remote messages. We have configuration details. We have indexes that allow us to quickly index into pieces. Git is a really interesting system, and I'm so glad that we get to dig through all the pieces. If you want a quick summary of all of the pieces, Git ready. This one will talk about each of those files in a little bit more detail. And I love that it talks about how each of the files work and how we can use them together. I've had a lot of fun being able to dig through this Git folder and look at all of the pieces. You can reach me on Twitter at Rob_Rich. For those watching this video later, definitely reach out to me on Twitter and let's continue the conversation.